Howdy everybody in YouTube land. Here we have an MTX Thunder 5400X. Another old school unit. By the looks of it, it looks like a multi-channel amplifier. No, here's something typical. 325s, I got a 30, a 35, and a 25. Yep, that sounds about right. That's fairly common in the car audio world. Let's just stick a bigger fuse in it. It'll work just fine, everybody. Yeah, no problems there. Anyway, looks like this has been molested because there's no labels cut. So someone has already been in here. But let's see, what do we have? We have a 25 watts RMS in the 4 ohms, so it's a 4-channel. And it's got a subwoofer. So this has front, rear, and sub. So this is a 5-channel. This is one of those all-in-wonder amplifiers, which is many channels but a master of none. So, alrighty then. Please stand by while I get all these screws out of here, because it at least has all of its screws. Well, mostly. Looks like this one's not going to be so easy, because again, someone decided to put flatheads in there. Whoever invented the damn flathead screw is a flathead, in my opinion. But the metal wraps around, and it looks like all this stuff is going to be obstacles. There's little micro screws there, and these I have to screw all these back in. Same thing on this side, it wraps around, so there's a screw there, and fairly annoying for the repair guy, but MTX was never known for wanting their amps repaired anyway. So anyways, I'll be back as soon as I tackle all of that. Alright, now that I actually got the lids off, let's take a quick look at the inside of this thing. This is an old one too, 1998. That's 20 years old. So this would be considered old school at this point. Again, sight, sound, smell. It smells really pungent, like something fried. Definitely something fried. Whoa. Wow, we got a cluster of extra Crispies in here. In a situation like this, when there's no schematics available, is I'd have to study the circuit design to figure out how it works. But I have an LM311. I have a CD4013. Oh, this is a Class D amplifier, a very early version of it. It looks like it has 4 channels of AB. I'm not seeing any physical damage in the AB circuit, but the sub channel, which is a Class D, this is a dead giveaway that it is a Class D amplifier, plus the output filters. Tells me that the Class D amplifier section has failed. So, looking and inspecting, see the CD4013 is the digital circuit. Chances are that's the oscillator. A lot of these early designs are fairly common. Looks like the power supply section, which is about the same on all MTXs I've ever seen, uses a transformer driven gate drive, which makes sense because this steps it up. Because when you have an input of, anywhere between 12 to 14 volts fluctuating, most amplifiers drive the gates of these MOSFETs with that voltage. So these can fluctuate, and when they do, your RDS on, or the resistance between drain and source, will float around based on gate voltage. You don't want that because it can cause power supply failure, and you can lose efficiency in the power transfer. So what MTX did was they put this transformer here, which is a step up coupling transformer. So these things see about a VGS of roughly 15 to 18 volts all the time, no matter what. So these things are driven with a stable voltage. So very rarely do I see the power supply sections failed in these MTXs. The only time I ever see them fail is if the output stage fails, which is more common than it should be. So, judging by this disaster, we have to look at the feasibility of repair, because I got to make sure, because the board is blackened from the explosion. And that blacking, yeah, that transistor just fell apart. That blackening is carbon tracing. So we have these two transistors split. Since this amplifier catastrophically failed, we can be pretty reasonably assured that the output stage is damaged as well. So I'm going to go ahead and take a measurement of that right quick. Chances are these are the drivers for the output, so it is likely that they explodificated. So what I'm going to do is I'm going to take these probes and I'm going to meter the output stage. Nope. Nope, that one's good. That's not so good. Then again, let me double check through trying to get these probes in the right spot again. No, I'm not seeing anything. Oh, that's a rectifier. That's a rectifier. So there's a FET. Those FETs could be just voltage regulators, because all I see diodes across them. No, I'm not entirely certain. Well, I got the same FETs over here. I got rectifiers here, and I got rectifiers here. So this amplifier is confusing, because I've never seen this exact model before. So let's check these FETs. Well, they're dead. 6 o'clock Sunday. That's the power supply. Yep, power supply. So you know what? No. Gotta be careful, because I'm reading through a transformer. Yep, they're dead. They're definitely dead. So those guys. There's a couple over here too. I got 2 FETs there and 2 FETs over here, which makes sense because this is the power supply section. So again, let me get my probes in a place where I can use parallelism to my advantage. Yeah, it's not. Okay, let's try. Yeah, it's not good. Yep, power supply is dead. So I bet you if I meter across power. Yep. So that's why there's 3 different fuses in it, because it kept popping fuses. Hey, let's just stick another fuse in it. Bam! Let's stick another fuse in it. Bam! Let's stick another fuse in it. Bam! Yeah, that ain't ever gonna work until you locate the fault. However, what I just noticed is we got left rear, left front, right rear. The only thing I'm looking for now is sub. I don't see there it is, sub positive, sub negative, and there they are. There's the output filter capacitors, and then the filter choke for the output stage. Must be low frequency because of the big how big that coil is. So that means I don't know where the output transistors are for that stage. They've got to be right here, which I don't see any damage to them. So what I'm going to go ahead and do is I'm going to go ahead and remove this heatsink so I can figure out what's under here. So with the heatsink removed, we have the rectifiers, DC rectifiers, SSP 45N20. So yep, these are the outputs. Unfortunately, they're no longer manufactured. The 45N20s they've been long since gone. The only alternative was the 42N20, which, and I'll be honest with you, MTX amplifiers are very, very, very picky on what output transistors you use in their circuit, because most of the time they're self-oscillating. This one just appears not to be, because this CD4013 gives it away. So I don't have shorted outputs at all. Well, the outputs are fine, so that's strange. Normally the outputs go, no, in this case the driver stage went. Huh. Well, you learn something new every day. Sadly, I don't know what values those are, so the only way I'm ever going to find out is if I'm very careful in how I go about. Let's reverse this around. If I'm very careful on how I go about viewing these. See if I can get it into focus here. Nope. Let's see. That one is a don't know. Some weird MBS. So I think it's the same as the one to the far left. So let's move to the next one. Get it out of the way. That's Q808. Let's see, the one next to it is cracked. But what is it? MPS 56. That's common because I've seen the MPS A56, which is the surface mount version of that one. So at least I know what that one is. What's the one behind it? MPS A06. MPS 0, yeah. That's the A. Okay, so I've got an A06, I got a 56, which means the one's next to it. Nope. There's an 06 over here. There's a 50. So this is the complement. Yep. So this is the complement of this stage. And that's MPS 8099. I don't know. I have to look that up. Anyways, so this one is not going to be as straightforward to repair, sadly. So yeah, I'm going to have to do. The only thing I can do is remove those transistors, make sure the carbon tracking hasn't damaged the board beyond repair, which it looks like it may have. And if that's the case, yeah, so if that's damaged beyond repair, there's not much I can do about it. But chances are the LM311 is the integrator to the circuit. Yeah, that's weird why that would fail, but the outputs didn't. Huh. I have to grab a Q-tip and clean up all the soot and check all those resistors for damage. Because it stuff it's almost like flames shot out of that, because you can see the soot just all the way down, all the way out to here. So anyways, I'll have to check this one out a little bit further, and the only way I can do that is to get approval for repair, because I have to replace those, or clean those up, replace those first before I can even begin doing anything else. So anyways, thank you for watching, and feel free to leave a comment if you have one.